User-defined functions, or UDFs, in Snowflake are custom functions that extend SQL's capabilities, allowing you to define your own logic for data processing, aggregation, and transformation. They're executed within Snowflake's virtual warehouses, ensuring security and optimized performance. Think of them as reusable code blocks tailored for Snowflake's environment. SQL UDFs are written purely in SQL. They're ideal for lightweight computations and deterministic operations. You can create scalar functions that return single values or tabular functions that return rows. They are easy to create and use for basic data manipulations directly within SQL. Let's examine a practical SQL UDF example for calculating discounts. This function takes a price and discount rate as inputs and returns the discounted price using simple SQL arithmetic. Here is the create function statement. It defines a function named calculateDiscount that accepts two float parameters and returns a float value. The SQL logic multiplies the price by 1 minus the discount rate. To use this UDF, call it in a select statement with actual values. For example, passing 100.0 as price and 0.1 as discount rate. The result would be 90.0, which is 100 multiplied by 0.9, 1 minus 0.1. The float data type is used for decimal numbers, providing flexibility for price calculations. Python UDFs allow you to leverage the power of Python libraries like Pandas and NumPy for complex data science tasks directly inside Snowflake. They run in a secure, sandboxed Python runtime, providing access to Snowflake data through input parameters. This allows complex analysis without moving data. This Python UDF demonstrates sentiment analysis using the TextBlob library. It takes text input and returns sentiment as positive, negative, or neutral based on polarity. The function imports pandas and TextBlob, then analyzes the sentiment polarity of the input text. To use the UDF, call it with a text string. For example, analyzing I love Snowflake returns positive sentiment. UDFs are created using the create function statement. You specify the function name, input parameters, return type, language, and the function's code. For a SQL UDF, the structure includes the function name, parameters, return type, and SQL code block. For Python UDFs, you additionally specify the runtime version and any required packages, along with a handler function. Finally, make sure to grant appropriate privileges so others can use your UDFs. When working with UDFs in Snowflake, consider these key best practices for optimal results. First, use UDFs for reusable logic to avoid code duplication and improve maintainability. This approach makes your code more efficient and easier to update. Second, monitor performance with Snowflake's query profiling tools. These tools help identify bottlenecks and optimize your UDFs for better speed. Third, secure your UDFs with role-based access control, or RBAC. This ensures only authorized users can access and modify your functions. Fourth, implement code signing to verify the integrity and authenticity of your UDF code. This adds an extra layer of security. Fifth, remember that Python UDFs cannot directly access external APIs. For external connectivity, use Snowflake's external functions instead. Finally, be aware of runtime limits, such as 10 minutes per execution. Design your UDFs to complete within these constraints for reliable performance. The future of user-defined functions in Snowflake looks promising, with several exciting developments on the horizon. Expect to see increasing integration of AI models within UDFs for predictive analytics and real-time inference. Low-code, no-code tools are making UDF creation accessible to a wider audience. Hybrid approaches combining SQL and Python will become more common. Future developments may include support for real-time streaming data and enhanced GPU acceleration for machine learning workloads. These advancements will further empower users to harness the full potential of their data within Snowflake's ecosystem.